Hello and welcome to Tribe Topper. In this video session, you are going to learn about Ohm's law and resistance. So let's talk about Ohm's law first of all. Now, what is Ohm's law? It states that at a constant temperature, the current that is flowing in a conductor is directly proportional to the potential difference applied across the conductor. So that means if I have V as the potential difference in a conductor and I is the current flowing through the conductor, and we are maintaining a constant temperature. In that case, the current that flows through the conductor is directly proportional to the applied potential difference. As we all know, when we need a greater amount of current, we will use a bigger battery, and when we need a smaller amount, we will use a bigger battery. So higher the potential difference, greater will be the amount of current that will flow through a conductor. Now, we can also write it this way. So V is proportional to I. So high current would mean a high amount of potential difference. So when we remove the proportionality sign here, we add a constant of proportionality, which is R. So the relation becomes V is equal to IR. And this is the famous equation of Ohm's law, that V is equal to IR. Now, what is R? R is known as, though it has been introduced as the constant of proportionality, but it is termed as resistance. So R, if we want to find out resistance, we'll say it's the ratio of potential difference to the current through a conductor. And if we look at the graph for such a case where you have, say, a metallic conductor, in that case, you go on increasing the potential difference, the current goes on increasing. Now here we have a graph which has been plotted. Say supposedly you performed the experiment and you got these readings. So current zero point 0.1, zero point 0.2, zero point 0.3 and so on amperes, and the potential difference is 0, 0.2 volts, zero point 0.4, zero point 0.6 volts and so on. You get a straight line. So if you find out the slope of this line or the gradient of this line between any 2 points, say let's say I take the point A here and B here, then what will be the gradient of this line? That will be the gradient of that line would be BC upon AC. Now, what quantity do I have I plotted along BC? That's the vertical axis, that's V. And upon AC, that's the horizontal axis, we have plotted I. And this ratio of V to I is called what? R, Ohm's law. So by Ohm's law, we know that V is equal to IR and the ratio V over I is R. That means, therefore, we can say that the gradient of a VI graph gives us, or it is equal to, resistance. So we can find out the resistance of a metallic conductor or an ohmic conductor from the gradient of a VI graph. Now, it's not essential that every conductor will obey Ohm's law. And so accordingly, we have some as ohmic conductors and some as non-ohmic conductors. So a conductor which is ohmic, if it is ohmic, it will be for an increase in the voltage across the conductor, the current also increases. And the voltage versus current will be a straight line graph, which will obviously give you a constant resistance. So as you can see in the first case, you have a straight line graph of I versus V, and that is an ohmic conductor, which will generally be a metallic conductor. But in case of a filament lamp, if you see here, this is a curve, right? In another case, semiconducting diode, again it's a curve. There is no other graph which is indicating a straight line. So those resistors are known as non-ohmic resistors. That means if the graph of the voltage versus current is not a straight line, then that is a non-ohmic conductors. And you have many of the examples as filament lamp, semiconducting diodes, neon tubes, thermistors, because in these cases the temperature does not remain constant, and so the variation of the current and voltage has a very different relationship than or as compared to a metallic and ohmic conductor. So the filament lamp, semiconducting diode, neon tube and thermistor, these are all the examples of non-ohmic conductors, whereas metallic conductors are the ohmic conductors because they obey the Ohm's law and they get a straight line for an IV or a VI graph. Now let's talk about resistance something more. I defined by Ohm's law that R is V over I, but that's a very mathematical definition that R is the ratio of V to I. But the resistance, what it means qualitatively, what's the actual meaning, that it is actually the opposition offered to the flow of current in a conductor. It's something similar to our motion on while walking, like we face friction. So when we walk, we cannot walk at like a great speed because of the friction. So friction is an opposing force. Same way here, when the electrons are flowing through a conductor, they also face that opposition from the conductor, and that is known as resistance. So we would simply define resistance as the opposition offered to the flow of current. Mathematically, it is the ratio of voltage to the current. And the SI unit of resistance is ohms. We also represent it as ohms. But what do you think could be the cause of resistance? So let's say we talk about a conductor and say this has a length L. The flow of current is because of the electrons that are all flowing aligned in one direction. But the problem here is that there is a huge number of electrons that flows through a conductor. So they are bound to collide with each other and with the walls of the conductor. So when they collide, they stop. But due to that potential difference that has been applied, they will keep on moving. So you have a flow of current because, sorry, here we would have a negative side and this would be a positive side. So this is positive, this is negative. The negative side is repelling the electrons and the positive side is attracting these electrons. But I would say due to a large number of electrons, so due to a large number of electrons flowing in a second, they collide with each other and with the walls of the conductor. Now, because they collide, they stop. So we'll say, therefore, they stop and start again. So that means there is an opposition being offered to their flow. They don't have a smooth flow. So the main cause of resistance is the collisions of the electrons. So that's all in this video session. In the next video session, you are going to learn about the factors that affect the resistance. Thank you.